Hello guys, this is Ms. Ozanich coming to you live from my kitchen table, and right now we are going to get this week started by talking about symmetry of graphs. And so the symmetry of a particular function can be odd, even, neither. Those are kind of your choices when it comes to symmetry. So we're going to look at these graphs and we're going to talk about what it means to have even and odd symmetry specifically. And then in key features in the next video, we're going to talk about what it means to have an even or odd degree of your polynomial and what that means for end behavior. So please don't get the two mixed up. One has to do with symmetry, the other has to do with behavior of polynomial functions as you go to infinity or negative infinity. So we'll talk about each of those. All right, so really you can actually determine whether or not you have symmetry just by looking at the graph, but I want to show you how you can also take the function and evaluate it algebraically to determine whether you have symmetry, a type of symmetry for your graph. So we're going to start with this equation right here. This y is equal to an x squared minus 2. And you can see that it has symmetry about the y-axis. So it has line symmetry about the y-axis. And if that is the case, this is going to be called an even function. Okay? So we can tell just by looking at it that it is cut exactly in half with a line of symmetry right along the y-axis. Now the other way that you can determine that a graph has even symmetry is to take your function, which in this case is f of x is equal to x squared minus 2, and we're going to evaluate that function at a negative x. Okay? Which means we're going to plug a negative x in everywhere we see an x value. And we're going to simplify that. So I'm just going to kind of keep simplifying my function here. I know that when I square this negative x, I end up with a positive x squared minus 2. And as you simplify, what you see here is you see your same f of x function. Okay? So the rule is if you have an even function, then if you evaluate f at negative x, it will equal your original f of x. Okay? It is the same. It turns out to go back to your original. And that will always be the case in addition to your line symmetry for an even graph. Okay? So let's go ahead and move up the page here. At any time, if you feel like you need to slow down or stop, you can always pause things, take notes, whatever you feel you need to keep your learning going. All right. Next, we're going to talk about the symmetry that you see here. And the symmetry you see here for this graph, and this is a graph of y is equal to x cubed, right? And this is called point symmetry. And it is symmetric about the origin, which means if you rotate this picture 180 degrees, right, you flip it on its head, it will look exactly the same as it does in your original. So imagine spinning this 180 degrees. 360 degrees doesn't count. That's just spinning it all the way around. But if you spin it halfway through 180 degrees about the point that is our origin, and it looks exactly the same, that is called point symmetry. Okay. So we're going to tackle this in the same way. We are going to take our function, which is f of x is equal to x cubed. we are going to evaluate this function at a negative x, which means plugging in a negative x everywhere we see our x value. In this case, as we simplify, we get -1, because our -1 gets cubed, it still remains negative, x cubed. And what you see here is you see this is not the same, okay? But one key piece of factoring out a -1 does give you your original function. Okay, so these graphs that have this symmetry are called odd. This is called odd symmetry. And so what will happen is it will be odd if for every value of plugging in f of -x, your result is -1 times your original f of x. Okay, and that is called an odd symmetry. Okay, so the key is really evaluating at this -x right here and seeing what your result is to determine odd, even, or neither. And again, you can do this visually as well. So if you come across a function where you're asked to determine whether it's odd or even or neither, you can evaluate the function at -x and see what the outcome is. Or you can also graph it and look visually at your graph to determine where your symmetry lies. Okay, so we've done one for even, we've done one for odd. Here is a case of one that is neither. And maybe you can actually see this just by looking at your function. If we look at this y-axis, it's not cutting it down the middle, okay? X equals 3 is not the y-axis. That does not count for a line of symmetry to make this graph even. It also does not rotate 180 degrees and look the same as its original. So graphs that look like this have neither odd or even symmetry. And again, the way we can tell is to evaluate our function, and the function for this graph, and you guys are going to learn how to do this very, very, very soon. But I'm going to go ahead and write this in here. It's going to be 2 times the absolute value of x. It looks like a -3, -2, and by the end of this unit, you guys will be able to do that. Take this graph of an absolute value function, look at how it's been stretched, look at how it's been shifted horizontally and vertically, and you'll be able to take a picture and write a function, or take a function and draw the picture. So this is one of our learning targets for next week, not quite this week. Okay, so let's go ahead and plug in f of -x and see what happens. Okay, so it looks like we are going to have to, oops, my absolute value symbol there, not a parenthesis, sorry about that, times -x minus 3, okay, minus 2. And simplifying this, really the only thing we can do here is kind of go down this path of, because it is an absolute value function, if I did factor out a -1 within these parentheses, I'm going to have an x plus 3 left. And I know what happens with my absolute value functions is any negative value would actually become positive. And if I continue along that line of thinking, then I am left with an x plus 3 in my absolute value as I take the absolute value of a -1 and just get 1. And you can see that at this point, this function that I have been trying to evaluate is not the same, okay? And the big reason it's not the same is because of this right there. So it's not the same. And if I tried to factor out a -1, let's try and factor out a -1 and see what happens. Let's see, -1, I'd have to factor it out of both of these pieces. So that'd leave me with a -2, an x plus 3 plus 2. And that does not look like my original either, right? It's not, that's not the original. So we're stuck, which means it's not odd, it's not even, it's going to be neither. So there's kind of the lowdown on how to classify your graphs in terms of their symmetry as odd, even, or neither. All right, see you in the next video, guys.